We are in section 5.8 of Math 95. In this section, we're going to build on the concept of factoring, and we're going to use it to solve equations. Along with that, we will also be doing some problem solving of some application problems. So before we start the actual solving process, let's get some vocabulary under our belt. For an equation, we need to always have a standard form to work with, a starting point. And so for the types of equations we're going to be dealing with, these polynomial equations, we want to have a polynomial in standard form. But we're going to set it equal to 0. So the polynomials are what we have been dealing with for the last several sections. The type of polynomial we will most frequently be using will be quadratic trinomials. So the easiest example to talk about as far as standard form would be something like ax squared plus bx plus c. There's our polynomial in standard form, decreasing degree order, and we will set that equal to 0. And our hope is to use factoring to solve this. And in order to use factoring to solve this type of polynomial set in standard form, we need to make use of something called the zero factor property or the zero product property. So if I had x times y equals 0, one of the ways this could be true is if x were to equal 0. Another way this would be true is if y were equal to 0. The zero product property states that if any factor of a factored polynomial equation equals 0, then the entire equation equals 0. If any factor of a factored polynomial equation sets to 0, is equal to 0, then the equation is true. So for us, what that means is that we are going to factor our polynomial in standard form, and then we'll set each of those factors equal to 0. Let's see what that looks like. So remember that if you see the word solve, apologize for that. If you see the word solve, what that means is find the variable value. So on this slide, we're looking for the x values. When I use the zero product property on this first factored polynomial, notice it's not in standard form, but it is already factored. When I look at my factors, I can recognize that this first factor will equal 0 when x minus 3 equals 0. And if I solve for x, I can tell this is going to happen when x equals 3. For the second factor will equal 0 when x plus 5 equals 0. And that will happen when x equals negative 5. And we're always interested in checking, if at all possible, and to check, we would plug each value into the original equation. Now, when you have something that starts out factored, we're not so interested in checking the values. We will when we are factoring ourselves because we want to check to make sure we factored correctly. So for this next factored polynomial equation, if I look at the first factor, this will equal 0 when x equals 0. These will be your favorite kind of polynomial equations because you really have nothing to solve. You see a variable out front, you know that it will be 0 when it is actually 0. That factor will be 0 when the variable is 0. For the second factor, it might take a little bit more time. 5x minus 7 equals 0, which will happen when 5x equals 7. I added 7 to both sides. Let me give myself a little bit more room. And this will be 0 when x equals 7 over 5. And it's perfectly okay that we have a fraction for our x value. That's fine. It's not a problem at all. So far, these have been the solutions that I have gotten. I'll box them so they're a little easier to see. What about an equation that we actually have to factor ourselves? Well, if I were to factor this trinomial, I'll use the tricks that we learned back in section 5.6 and 5.7. A key note is that it's very important to always set your equation equal to 0. Even when you're factoring it, always have the equal 0. Now when I factor this trinomial, I know that I need two things that multiply to a positive 5 and add to a negative 6. This tells me that they have to have the same sign. This tells me they both need to be negative. So I'm going to have an x minus and an x minus. I'm pretty sure that this should be x minus 5 and x minus 1. So when I solve this, I'll wind up with x minus 5 equals 0. So x will equal 5. And I'll have x minus 1 equals 0. So x will equal 1. Now, since I had to factor this, I am very, very interested in checking it. So what I will do is I will put the 5 where the x was. And check to see if I get 0. So I get a 25 minus 30 plus 5. That equals 0. 25 minus 30 is a negative 5, plus 5 equals 0. I've also checked the other value. So 1 squared minus 6 times 1 plus 5 should equal 0. 1 minus 6 plus 5, in fact, equals 0. So I know that I have correctly factored and solved this equation. So I will box those answers. We have another trinomial to factor. Let me try that again. I don't quite know what happened there. I grabbed the wrong pen. Hang on one moment. I wanted the select pen. Grabbed the wrong one. Alright. So, if I have something like 3x squared plus 5x minus 2 equals 0, I could go through all of my old steps. 3 times negative 2 gives me negative 6. I'm looking for factors of negative 6 that add up to 5. I'll review that. So factors of negative 6 that add up to 5, I'm going to have a 3x. Grabbed the wrong one again. Pardon me while I have technical difficulties. Let me see what we have now. I'll do one more time. Put the recording block back. Grab the appropriate pen. Alright, here we go. So, we had 3x squared plus 5x minus 2. 3 times negative 2 is negative 6. I need factors of negative 6 that add up to positive 5. So I will have a 3x squared minus 6x plus 1x minus 2 equals 0. Just a reminder of our AC method of factoring, our non-one coefficient. Factor this by grouping. Factor out a 3x. I'm left with an x minus 2. And from this side, they only have a 1 in common. So factor out the 1, x minus 2. This whole thing still equals 0. As I finish factoring this, I get a 3x plus 1 and an x minus 2 equals 0. Set each factor equal to 0. 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1/3. For the other factor, if I've got an x minus 2 equals 0, x will equal 2. Now to check, I will plug my x values back into the original equation. And I want to see if this equals 0. So you could do this on your calculator. I will find it quicker to do so by hand. 3 times 1/9 plus 5 over 3 minus 2. Does that equal 0? This will become 1/3 plus 5/3 minus 2 should equal 0. 1/3 should have been a 3 under that 5. 1/3 and 5/3 make 6/3, which is 2. Minus 2 does equal 0. So the negative 1/3 works. Let us try the 2. So 2 squared is 4, so this is a 3 times a 4. 5 times 2 is a 10. And I believe I did something wrong. I see what I did. So this is why we always check. I have made 2 sign errors in a row. This 1/3 should have been negative. That would make this a negative 5/3, which would in fact make this not equal to 0. But I was lazy with my negative signs and I didn't catch that. I caught it down here because I didn't have as many negative signs to deal with, and as I looked at this, I noticed my sign error came into play right here when I factored. That is frequently where we will make the mistake. So what I'm going to do is I'm going to stop the recording. I'm going to jump back in on this problem, solve it again correctly, write out the notes of what we do, and then move on to another problem.